Hi, I'm an old guy and I do maths. Cosine of 3x equals negative a half. What is the value of x? What are the values of x, to be more precise? We have a domain between 0 and 2 pi, so let's get to work. First step. We are going to change the domain. We're going to multiply the domain by this number here. So the domain is now from 0 to 6 pi, and we will reverse this process towards the end of working out our solution, and you will see that in action, and I hope that the result will make sense to you. So that's our first step. Second step is to sort out what our base angle is. Notice that I'm just working in positives here. I'm looking for our base angle, and I've set up this triangle. It should be familiar. 1 root 3, 2. This is pi on 3 here. This is pi on 6 up here. We're looking for pi on 3, and we're looking for, at the moment, the cosine. Now the cosine of pi on 3 is the adjacent over the hypotenuse, which is 1/2. That's what we're looking for, except that we're looking for where it is negative. And the cosine is negative in quadrants 2 and 3 of the unit circle. The next step is to make the leap to understanding that there are 6 solutions. So I've just noted that there. Let's go through the motions of this. Now, we are looking for where pi on 3 is actually negative, where the cosine is negative here. It's negative in these 2 quadrants, so we take our x-axis and we subtract pi on 3 to get this value, and we add pi on 3 to get this value. These are both places where the cosine is negative. This is not to scale, so please don't imagine that it is. Cosines are positive here and here. So bear in mind we also have to do 3 revolutions of this circle, because our domain is now 0 to 6 pi. So let's start. The first revolution takes us from here to here and then back to here. So that is pi. Pi is here. And subtract pi on 3, we're there. So that's pi minus pi on 3. The next one is pi plus pi on 3. Then we go round the unit circle again. So our next stop is here. 1 pi, 2 pi, 3 pi, minus pi plus pi, and I've just put plus or minus pi on 3 here. I should have said pi on 3 when I indicated this. I hope I did. I may have slipped up. So this is 3 pi minus pi on 3, 3 pi plus pi on 3. And again, we go round the unit circle. So we're at 3 pi, 4 pi, 5 pi, minus pi on 3, plus pi on 3. And these are the angles that we're going to be working with. Now, my next step is to simplify those angles. So pi minus pi on 3 is 2 pi on 3. Pi plus pi on 3 is 4 pi on 3. Then 3 times round the unit circle gives me 9 pi on 3 plus minus pi on 3 gives me 8 pi on 3, plus pi on 3 gives me 10 pi on 3. 3 times around the unit circle gives me 15 pi on 3, minus pi on 3 gives me 14, plus pi on 3 gives me 16 pi on 3. And that all equals 3x. And this is where we turn back the process that we initiated with the domain being multiplied by 3. This all equals 3x. So what does x equal? Well, this is what x equals. we divide each of these by 3, which is very, very simple to do. We simply multiply the denominator by 3. We get 2 pi on 9, 4 pi on 9, 8 pi on 9, 10 pi on 9, 14 pi on 9, 16 pi on 9, and they equal x. And I have one more thing to show you. If I take that last measurement, which is 16 pi on 9, and I divide 16 by 9, this is what I get. I hope you can see that. It's 1.78 effectively. That is within our original domain. So we have, by expanding and effectively multiplying, and then by dividing, we have got to a point where we have 6 solutions within our original domain. And you could graph this and check it. It will hold up. I didn't do this using graphs because it gets messy. This is probably the most elegant way in which you can do this. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.